Alright everybody, welcome to another update, and we are here with one of the final updates probably. I might do more updates than the rest of the outbreak, but as for now I think this is going to be the final, I guess you could say episodic, in terms of the breakdowns for the event that happened between the March 14th and 15th, and this is the Tylertown EF4 tornado, and we might brush on the Tylertown EF3 tornado that also went through the town. But I mean, that's just a really insane sort of thing to happen. And the last time I remember that happening was April 12th, 2020, where Saheb had an EF4 tornado go through, and I believe an EF3 tornado went around the exact same area as well. So a very similar event in a very similar type, sort of like a location, and it is a susceptible location, but still nonetheless a very impressive and rare sort of feat for that to happen. But ultimately, we're looking at this violent tornado that was very significant in a lot of ways, and produced the first tornado, and actually the second tornado emergency of that sequence. The first one, I believe, was at Bakersfield, or the worst place. I think it's Bakersfield, Missouri, that produced the first tornado emergency since about like May 26th, 2024. So quite a long time after it's been after since the tornado emergency issued, and this was the second one to be issued. And then I believe there's two tornado emergencies issued with this one. One was an extension to the initial one, and here with this video you can just kind of get a grasp of the tornado itself. So I mean, there's just a lot going on. I mean, even in this footage you can just make of this huge updraft, and really we're talking about like a large supercell. We're talking about on the larger side. More so, I would say it's probably a classic supercell rather than high precipitation, because there was a decent enough visibility to see this, and you can see it chug along in the rain, and so there was certainly a very large tornado right there in the background. And normally when you see these sort of structures, where would you observe them? One of the things is, well, when you see a tornado like this form, it would form so that the updraft, if you look at it in radar, which will show right now, and we will look at this first. Well, the updraft is actually wrapping around in a C shape around the downdraft, and the RFD, the rear flank downdraft. So what you'd have is this updraft being encircled around this, and on the very tip of the hook, the far right side, is where you see a wall cloud typically develop with tornadoes. That's where the major percentage of these tornadoes typically form, and even the violent ones would typically form in that region. Now, with such a violent tornado, you'd have such low LCLs with such a low cloud bases, with even lower wall cloud, and potentially a tornado cyclone. So essentially the whole mesocyclone is rotating with the tornado very close to the ground, almost as if it's part of the tornado circulation. And you would sometimes see that also that would also be in the same region to the tip of the hook, and so that's where you'd see these observations. And one of the things is a risk is when storm chasers they make maneuvers to get ground observations, or even drone observations nowadays. They would do a hook slice where they'd maneuver through this hook region in the southern flank of the supercell to go through the hook in the rain to see the tornado on the other side. Now that's a very risky maneuver, but due to a lot of variables. But that's one of the ways to allow for observations, and sometimes even the local residents they become accidentally part of the capture where they can see the tornado. And one of the first footage I showed was just an amateur couple that took a recording of it because it was in their view, and that's what typically occurs in these situations. And just going back to this, we're looking at the overall outbreak. This is mostly in Mississippi. In fact, this is entirely in Mississippi. This is just preliminary, and I do believe the outbreak as a total produced 112 tornadoes as of preliminary data. That reminds you of the December 28th, 2024 sort of outbreak, which produced about the same, in fact I think slightly more, but this is a very significant outbreak nonetheless. Compared to March 31st, 2023, we use an intensity sort of scale guidance. It's the adjusted Fujita scale, and this point scale system kind of represents the significance of the outbreak in a very simplified fashion. So what it does is it produces a total number of points. And so, for example, the March 31st, 2023 outbreak produced about 1,800 points. And now what they do is they take the ratings of the tornadoes, the track length, and then they do an adjustment factor based on the way the tornadoes are rated now compared to the previous back many years back when they used to rate tornadoes with the Fujita scale, because this data is coming from a consensus of 1973 to 2011. This specific value that we're using as a modifier, it's pertaining to that sort of error. So we have to put a factor to account for the rating system and the way it was, and so you produce this total value, and this 1,800 is a very significant number for the March 31st outbreak. That's very high end. Typically over 1,000 is like only the top 2-3% of outbreaks, so very rare nonetheless. But this outbreak had a score of 2,800. Now that's 1,000 points greater, and that's mainly due to the significant nature of long track violent tornadoes and cyclic nature of strong tornadoes being produced at the minimum. And when you have very favourable kinematics and thermodynamics, and probably more so on Friday than this specific outbreak, it was very favourable down here. And in fact, most of these tornadoes were quite significant. It's just depending on the structures they hit. A lot of these tornadoes were large, wedge, probably stronger tornadoes. I mean, very likely most of these tornadoes that in the southern region, mostly these longer ones, Melba, Bassfield, Hot Coffee, Paulding, these were probably of EF4 intensity at least. There were certainly large wedge tornadoes that just ripped through the forests mainly, and a couple of structures, but not enough to qualify for a higher rating. And certainly these two tornadoes down here were probably of EF4, EF5 intensity. The Kentwood, Tylertown, definitely, I believe it was, based on the observations of radar data and assumptions on radar observation, and uses calculation and the visual damage observed. And I think I went on a tangent a little bit, and I was going to say something about I think it was the intensity score. So with that high intensity score, it's very rare, because I believe that's at the fourth largest points on record with other compared outbreaks. So it's very up there. And I was mentioning about the very favourable thermodynamics and kinematics. When you have such favourable dynamics, it can produce a minimum of like a certain intensity of tornadoes based on those dynamics. We look at April 27, 2011. It was a high, it was high in the analogues for this outbreak, and really because that outbreak produced multiple significant tornadoes back to back in the cyclic nature, even up in the long track, and a lot more high intensity than observed. And we can use Werman et al. 2024 to thank that. But one of the things is that was a very significant thing about that outbreak compared to many other significant outbreaks that have occurred in the past. And this outbreak had some semblance where it produces multiple strong long track tornadoes, and that's why when you have such favourable thermodynamics and kinematics overlapped, you can produce an outbreak where the minimums of significant tornadoes is just like between EF2 and greater. And it's you can see how, I mean, this is kind of it's not necessarily representative, but this outbreak did not produce nearly as many cyclic long track tornadoes, at least from a long track perspective rather than intensity, because I do believe a lot of these tornadoes were of high intensity. But nonetheless, this is certainly an outbreak that we've talked about for quite a long time, and probably a lot of research going behind this outbreak as well, and we're looking in the future as well for other outbreaks that you can use this outbreak as a signal to what future outbreaks could be like, because we do have some outlooks on the SPC in the future for significant severe weather. So I believe this is one of the DIs that were provided with the highest EF4 rating. I believe this tornado was rated 170 miles per hour, EF4, and it was mainly due to this well-built structure. And one of the things now is they don't rate family homes, I believe, EF5 anymore, and I do not believe that actually occurs anymore. That was one of the primary reasons for the F5 rating, and when F5 was used, and even some of the EF5 ratings that were used. But this sort of structure no longer is able to capacitate for EF5 ratings anymore. So despite people's interpretations, it is not something that can occur. But still, a very well built structure, still is anchored, and it was largely swept clean. So that really did provide for the higher rating. And one of the things actually we do see is some of these. I'm not sure if these sill plates are still lined to the base with some of the anchor bolts. So I certainly see that this is of violent intensity. And one of the things is, for a higher rating, you'll see some of these sill plates ripped off even, and some of these anchor bolts twisted for a higher rating. But largely, I actually do agree with the National Weather Service is damage ratings here. I could see them issue this as a 185 DI, because still violent tornadoes can be produce that sort of damage at 185 miles per hour as well. But the main thing is the intensity is always going to be much greater. This house just was not enough to justify for a greater rating. Now this is one of the things that is almost just EF5 tornado damage like. Now I don't often use such significant analogues with tornadoes, but this tornado's tree damage, it's very similar to some tree damage that occurred. I think the Silverton or another tornado that occurred last year, very significant mesquite tree damage in West Texas. But this in the Dixie Alley comparison, one of the best analogues for this is the Smithville EF5 tornado, and it almost produced a very similar damage to this. It was completely flattening, very extreme debarking, and very extreme wind rowing that occurred with that tornado in such a short span of time. And really, this sort of nature that's produced with the debris and the damage, a lot of even some granulation going on, but a lot of this debarking and significant tree downing with the wind rowing is very reminiscent of the EF5 Smithville or even the New Wren tornado. They produced very similar to this. So that is something to consider about how intense this tornado was. And one of the things is, we actually have one of these radar loops with all four of the radar products, main significant radar products, that kind of show the evolution of this tornado, and really fascinating, to be honest. So you can see the evolution. So we have the reflectivity in the top left, the velocity product here in the top right, and differential reflectivity, I believe, in the bottom left, and then I think we have correlation coefficient in the bottom right. And so you can make a very good observation on the evolution of the supercell and the way the wind velocities develop, and you can see just how quickly it intensifies. You can see how quickly that hook becomes pronounced in the top left. Sorry for the low resolution of the imagery. This imagery was not of any higher resolution, but at least we have this observation. And despite the wind velocities kind of being hard to read, I did some calculations and some observations. Some of the wind velocities were extremely high, and certainly I believe there's a between 95 to 100 VROT values, so that's definitely significant, and more so in the 200 mile per hour range. And yeah, with such a tornado, it's not much of a surprise. And one of the things is often, as used before with ratings, when you have a tornado rating, tornadoes can be 1.5 ratings above the measured damage, or 20 meters per second higher. So yeah, really, the tornado could have been like using that and the idea of wind velocities near surface and how strong winds allow to be transferred to near surface. This tornado could have at least had wind gusts produced upwards of 220, 230, 240, based on even the tree damage, 250. So I'd probably put an average around 230 at least, to be completely honest. And even with ground relative observations using tangential wind speeds and translational wind speeds, which the strongest would be the southeast side of that tornado, you would see probably wind observations up to 250 miles per hour. So certainly a violent tornado, and I'm certain of that. And you can see that evolution really persist. And yeah, one of the things is you can see the debris ball also maintain. And one of the things you can also see is debris cloud being formed in this forward flank, where the debris gets alofted and pushed into the mesocyclone. And then you can also even see the debris ejections with this tornado as it violently ejects that debris out from the core of the tornado. And that can occur with RFD surges and other cell mergers, and sometimes tornado wind intensity fluxes and size flux. Sorry. Yeah, tornadoes they aren't a fixed evolution where they become much larger and slowly incline linearly to larger size, or decrease linearly to smaller size. We can see this in the Greenfield, Iowa tornado, for example. When it went through town, it was shrinking coming towards town. It became like 2 times the size just as it came closer to town. Then it shrunk very dramatically again, and then it kept shrinking, and every now and then in between hitting the houses, it became slightly bigger, slightly smaller, slightly bigger, slightly smaller, and then it continued that nearest end, becoming much smaller, but still very intense. And so the evolution of these tornadoes is not very of a linear fashion. There is that flux really in the way the size of the tornado and the intensity of the tornado, even in the final stages of the tornado's life. And with that, I think I have everything I wanted to say. One of the other things, I think I should have just mentioned this at the very beginning when I was showing the video, was you could actually see the horizontal vortices in the tornado, and that was really interesting, because not a lot of amateur footages are able to capture that phenomenon. So it's quite a rare phenomenon to occur, and really in favourable environments you can see that. So it's very interesting to see that footage and how much detail we could see in it. It kind of reminded me of I believe it's the Albion, Illinois 1990 tornado that produced very significant horizontal vortices, and there were studies on the horizontal vortices afterwards in some research papers. And yeah, with that, I think I have said everything I wanted to say about this. So with this, I'll see you guys in the next videos.